Good day, viewers. You are welcome back to Tindanious Maths and Science YouTube tutorials. If you are new here, kindly visit my previous lecture videos on range and domain of piecewise functions, type 1. Alright? Okay. Let's go straight to the point by considering questions. Find the domain and range of the function f of x. And secondly, find the domain of h of x. So, viewers, we are going to graph this separately, and merge them together, okay? And the domain of this function is the union of the domain of this and the domain of that. Okay, that will be the union. And the range of the function f of x is the union of the range of this to the range of that, and that will be what? The range of the function f of x. The same applies to this, okay? So I have x plus 1. Since I want to graph, okay, I will need my x coordinates and my y coordinates, right? Good. So the interval x is less than 2. So I have x then y. This way. So if this is 2, let's say 3, let's say 4, let's say 5. But viewers, let's look at something. It said x is less than 2, okay? So that means I have to approach the negative values, okay? So if you have the number line this way, this is 0, this is, let's say, 1, this is 2. So it's facing this side, okay? So let me start from let's say I have, if this is 2, let's say I have 1 here, okay? I have 0, -1, -2, alright? Then 2, somewhere negative infinity, right? Because it's pointing towards the side approaches, it's approaching the negative values, and you don't know the end point. So let's say somewhere to negative infinity, okay? So let's end over here for -2 for now. Then if you put -2 into this, what do we have? -2 plus 1, I have what? -1. So if I have -1 plus 1, I have 0. 0 plus 1, I have 1. 1 plus 1, I have 2. 2 plus 1, I have what? 3. So I can graph this. Okay, then for x plus 3, what do we have? We have x is greater than or equal to 2, right? So I need my x and my y coordinate this way. So I'll start from 2, right? So I have 2, then 3, 4, let me end at 5, okay? Then to somewhere positive infinity. Do you get that way? It will start from 2, then to somewhere positive infinity. Okay, so let me end at 5. Now, if x is equal to 2, what do I have? 2 plus this is 5. If x is equal to 3, so I have 3 plus this 3, I have what? 6. If x is equal to 4, what do I have? 7. So for 5, 6, 7, what do I have? 8. Alright, good. So viewers are going to plot this and that on the same graph. So viewers, we are going to plot this, okay? So I have -2, -1, -1, 0, 0, 1 in that regard. So I have -2, -1. So I have -2, -1, negative 1, 0, 0, 1, 2, 2, 3. These are the coordinates for this, okay? Let me plot it on a graph. So I have negative 2, negative 1. This is first negative 2 here, then negative 1 somewhere here. Then negative 1, 0, negative 1, 0 here, somewhere here. This point, I have 0, 1, so this is 0, 1, somewhere here. This point, okay? Then 1, 2. This is 1, then 2, somewhere here. Somewhere here, okay? Yeah. Then I have 2, 3. 2, 3, 2, 3. Where is 2, 3? This is 2 and 3, somewhere here. You can decide to add the rest to infinity, right? So let me draw a straight line to pass through the points. Okay, so I have this somewhere here. Alright? It's not drawn to scale, but just draw a straight line to pass through this, right? So somewhere here. Approaching what? Negative values. Right? Good. Now, look at the condition. S is less than 2. Where is my 2? This is 2, right? So let me trace this to touch here. So I can do away with this side, right? Then what happens? Is it closed or open? We don't have any bar over here, right? So therefore it is open at that end point. This simply means it is closed. This simply means it is open at that point. So I'll open it at this point, this way, as simple as that. So from here down to the negative values, approaching negative infinity. Then what about this? X plus 3. There's a coordinate 2, 5. I have 2, 5, 3, 6. We have 3, 6, 4, 7, 5, 8. This way. Let's plot this. We have 2, 5. Where is 2? This is 2 and 5. 5 over here, somewhere here. Then 3, 6. This is 3, then 6 somewhere here. 4, 7, 4, then 7 somewhere here. 5, 8, 5, 8 somewhere here. Then what have you? So this simply means you are starting from 2. Okay, so there is it. You draw a straight line to pass through this point. Somewhere like this, okay? It's not drawn to scale, but if you have your meter rule, then you just draw it, okay? Now, the x is greater than or equal to 2. Where is my 2? This is my 2, right? Here. Somewhere here. Is it closed or open? It is what? It is closed because of the bar. So that means I'm going to shade that point here. That means you are starting from here, okay? Then straight to positive infinity. Do you get it that way? Yeah, because it continues that way. It continues to the positive values. It will approach bigger values, right? And this will also what? Point towards this side, approach negative values. It will approach negative, or it will approach what? Smaller values, right? So how do this way? Good. Now, how do I write the domain for this function? So this is simple. Okay, so the domain is, now, this is 2, right? Okay. Then this is 3, right? Let's focus on the domain first, okay? Now, you are starting from somewhere 2, okay? From 2, then 2. Negative infinity, right? From 2. Open at 2, then 2, negative infinity. Or I said you can use the graph or the table. Look at the table. Look. See, from here, it will approach You see, it's approaching negative values. This is what the end point. The end point here is that's negative infinity. Is that also good? So that means from here, okay, the input here is 2, right? So we are starting from 2. Is that also good? Now 2 to where? Now 2, then up to where? Somewhere like negative infinity, right? Then to somewhere negative what? Infinity. Is that also good? But it is not proper to write your coordinates this way. Because so far as the number line is concerned, 0, so you have, these are the positive values, okay? And these are what? The negative values. Is that also? So the negative will come before what? The positive. So the negative infinity should come here before 0, then positive what? Infinity. So as a result of that, this one will be written as what? That's negative infinity, then 2. As simple as that. Remember, it is open at where? At 2. So there's it. So here, this is my 2, right? Then to where? Then to negative infinity. It goes this way, up to negative what? Infinity. So this is the domain for this function only, right? Good. Now let's consider this. Now for this, look, it starts from where? From 2. Is that also? Look, from here, this is 2. So we have 2 over here. Now is it shaded? Yes. It is shaded simply means that endpoint is included. That endpoint is inclusive. In other words, this is what? This is a closed circle. Because this place is included and it has a closed circle, where this is the notation for that. So whenever we see this, it means, oh, okay, 2 is included. 2 is shaded. That's the endpoint, right? Good. Now to where? To where? To somewhere what? Positive what? Infinity. It goes that way, right? It goes this way to positive what? Positive, then what? Infinity. So the domain, okay? So now the domain would be what? Would be this. You have what? From negative infinity, then to 2. Is that also? And remember, we said the domain of the function is the domain of this union the domain of this. So, okay, to get overall domain is simply the domain of this function, okay, union the domain of this function. That will be the domain of the function, okay. So the domain of this function is where here up to infinity, right? Please, it doesn't mean you are starting from 2, okay? You are not starting from 2 because this place is open circle, okay? This is open, but this place is what? It's shaded. The shaded means you are starting from these 2. That means 2 is inclusive. But when you open it at this point, it's not shaded. It means you are not starting from 2, right? Good. That explains why it is what? It is open at 2, and it's also open at infinity, negative infinity. Is that also somewhere like this? You see, open at here and also open at this point, right? Good. But because this place is not open, but it is rather closed, what do? That's why we have what? We have this notation. So it is the domain of this. The domain of this is what? Is negative infinity to 2. There it is. Then union the domain of this. And the domain of this is where? Starting from 2, then to positive infinity, which is what? Which is, we have what? This 2, then to what? That's positive infinity this way. Like this. As simple as that. Okay, you don't know the value for negative, right? You don't know the end point. So that's why we have what? This is what? This is open, right? This is open. Open simply, we normally use open when you don't know the exact endpoint, okay? But when you know the exact endpoint from, for example, here you know the exact endpoint, which is 2. That's what we use for this notation. Do you get that? That's the main difference between this and what? And that. Or this and what? And that. As simple as that. So, in other words, the domain of the function would be, remember from our previous lecture videos, we said you will pick the first coordinate here, okay, and you pick what? The second coordinate here. That's simply your domain. So our domain is now what? Negative infinity. Then to what? Positive what? Positive what? Infinity. As simple as that. That's the domain of the function. What about the range? Range is just what? The output, right? So from here, this is the output. I have what? I have 3. Then from here, the output here is what? It's 5. As simple as that. So the range now becomes, what do we have here? Viewers, look. From here, we have, when I trace the 2, okay, what do I have? This time when I trace here to touch the y, as I have 3. So I have 3 here. You get that? Remember, this is open, okay? So this is open at 3. Then comma, now to where? Now 2. Look, there is it. We are considering this function. This function, right? So we start from 3. Let me use the table here. 3. Viewers, look. This is the 3. You get it that way. So this is the 3. And the second one, you realize you have what? I'll show you the second one on the graph. So this is the 3, then to where? That's the question. Then to where? Then to negative infinity. Negative infinity this way. But remember, it is not proper. Okay, so this will be negative infinity. Then 3 this way. Okay. Then for this, look, this is 5. Right? This is 5. So I have 5, but this is shaded, right? So I have 5 here. Then to where? Then to positive what? Infinity. Positive what? Infinity this way. So the range is just the combination of this, then to this. That will be the range of the overall function. So the range now is equal to here, right? So 3 to the negative what? Infinity, which is this, right? So I have the negative infinity this way, then I have what? My 3. Then union, what do I have? Here. This is what? 5. This is 5, then to where? Then to positive what? Infinity. So I have 5, then to what? Positive what? Infinity. This is infinity, not 8, okay? So viewers, so therefore the domain, okay, is simply what? Negative infinity. Please permit me, my infinity, something like this. Oh, okay, this is infinity, not 8, okay? Then I have 3 here. Then union, I have 5, then positive what? Infinity this way. Viewers, this is the range of the formula, as simple as that. Now, the second question, find the domain of h of x. In other words, you have to draw for this, draw for that, and draw for that, right? But let me just give you a simple trick to write the domain of this function. So remember, for the domain of the function, we are interested in the least value, okay, for the x coordinate and the highest value for the x coordinates, right? So looking at this, from -6 to -3, -3 to 4, 4 to +6. So the domain is, so you have x is such that x belongs to all real numbers, okay? Where, look, considering this and that, which one has the least value for x? It's -6. Is that also? So it will be -6, okay, less than x. Then what is the highest value for the x? This is the least. You've taken this. Look at the positive values. You have 4 and 6. We have 4 and +6. Which one is the highest? It's simply what? 6. But looking at the 6, what do we have here? We have what? Less than or equal to. So less than or equal to. No, somewhere else. Negative is less than or equal to. We have this. Negative is less than x, okay? Less than x. Then less than or equal to 6. So less than or equal to what? 6. Viewers, this is simply the domain of the function. So you account for the least value of x, which is -6. Less than x. You have it here. Less than x. Then you pick the highest positive value. What do we have? 6, right? So this is the 6. We have what? Less than or equal to. We have the less than or equal to. What do we have? X and x. Therefore, this is the domain of the function. See you next time. Bye.